Hey all. So I want to go over another imputer here, and this one is an iterative imputer. And what makes this one different is this is multivariate. So K and N was also multivariate as well because it took other features into account as well. With this one, what it's going to do is it's going to recognize patterns as well between like your weight in your deadlift or your weight in your run 400 or something like that, and it's going to use data based on that to actually impute the values. So it's kind of like having a model within a model, I guess, is kind of my understanding of it. And what's also interesting about this one is it is experimental, so you'll notice you have to actually explicitly turn it on in order to use it. So I'll go ahead and show you how to do that. So let's get into it. So the first thing that we need to do is we need to actually turn this imputer on. So the way that we do that from the documentation is we just come down here and we do a separate import. This isn't the actual imputer. This is just the thing to actually turn the iterative imputer on. And notice that we have this comment here, the no QA. And so what that does is it's a special comment that's read in by the rough linter that we have that basically says like just even though this isn't used anywhere, just ignore it. Don't throw up any linting flags. Now that we have it enabled, what we need to do here is go to the impute package that we have and just turn on iterative imputer like that. And then, so when we come down here to our impute method, here I have it on my clipboard. All right, so iterative imputer. Now we're putting max iterations as 50. So, remember how I said it's kind of like a model in a model? So what it's doing is in order to find correlations between these numeric columns here, it's actually running a regression in the background to be able to find correlations between that. And the max iterations here is the number of time it iterates to try to find a regression between those. So that being said, if you have a higher amount of iterations, it's going to be more accurate, presumably, but at the cost of it's going to take longer to actually get that, and it's going to have more of a performance impact. What we can also do on the iterative imputer is we might not need all 50 iterations. And so if we can reduce that number, then it's going to improve performance, right? But we don't know how many iterations we're going to need. So what we can do in iterative imputer is there's a parameter called the tolerance, which is just TOL, and that means that in each iteration the estimations are going to get better, right? So by setting tolerance, we're going to compare the estimation in each iteration, and if it's only improving by say a very low amount, by say like 0.02 or something like that, just some random value, then we don't really care about that. That's not going to move the needle much in that direction. So in that case, we don't need to spend the extra compute on that. So that's what we can do. So we are going to set that. We'll set that to like 0.001 right now. And then that should help us. One more thing to keep in mind before we run this is we are eliminating it again to 30,000. And again, that's just to make it so that in order to run this, it only takes a couple seconds rather than like a couple minutes, just so that we can quickly iterate on what we have. So let's go ahead and run that. And you'll see it finished up pretty quickly to 1,200 athletes, which is fine. Okay, so the test scores are really good. The train score is 100%, which that to me is a pretty big red flag that we're overfitting in that case. Even though the testing score is also very good, I would rather actually do gradient boosting here because we have the train and the test score they're closer together. We're sacrificing like 6% on the test, but on the training score we're very close. We're only 12% off on each. So that's just another iterator that we can use. This reveals we should probably go back to gradient boosting now that we have this impute method figured out. So thanks for watching, and I will see you in the next one.